हेलो फ्रेंड्स, वेलकम बैक टू माय यूट्यूब चैनल। तो कैसे हैं आप सब? उम्मीद करते हैं आप सभी अच्छे होंगे। तो जैसे कि आपको पता है, हमने एक क्लास 10th का मैथ्स का एक चैप्टर शुरू करा था। इस चैप्टर का नाम था रियल नंबर्स, यानी कि वास्तविक संख्याएं। ये क्लास 10th में ये मैथ्स का चैप्टर नंबर 1 है। आज का ये जो सेशन रहेगा, ये इसी चैप्टर से रिलेटेड रहेगा और ये आज का इस चैप्टर का आखिरी पार्ट रहेगा। तो चलिए शुरू करते हैं आज के इस सेशन को। Alright, so this is the last topic of this chapter and first topic of this session, that is revisiting a rational number. In class 9th, we already did introduction on irrational numbers. We also know that rational and irrational combine to form real numbers. So in today's topic here, we will prove on irrational number, that is root 2, root 3, root 5 are irrational numbers, where in general we can write irrational number like this. Here P denotes a prime numbers. It means that irrational numbers are made from prime numbers. So now the question, what are prime numbers? So prime numbers are those numbers who has only two factors, that are 1 and the number itself. We have example that root 2, example like 2, 3, 5, 7, 11, 13 and so on. So these are the example of prime numbers. Now to start with this topic, first of all we need to understand what are rational and irrational numbers. So we all know that rational numbers are those numbers which can be written in the form of E upon Q, where E and Q are the integers and the condition is Q cannot be equals to 0. So these are called rational numbers. In the same way, if the numbers which we cannot written in the form of E upon Q, then those numbers will be irrational numbers. So in today's topic, we are going to prove on irrational number. Like we will going to prove these numbers are irrational numbers. So to prove these numbers to be irrational, we will use a proof that is based on the fundamental theorem of arithmetic. We already discussed this theorem in the previous videos. So let's start this topic. Alright, so let's start it. Before proving irrational numbers, first of all we need to understand this theorem, which is going to help us to understand or to prove irrational numbers. So let's understand first of all this theorem. So let's begin. Alright, so here written, let P be the prime number if P, it means that P is any prime number, and if P divides A square, then P divides A also. I'm again repeating, let P be the prime number if P divides A square, like that, then P divide A, like that, where A is a positive integer, any positive integer. Okay, so एक बार इसको फिर से बोल रहा हूं मैं, लेट P बी द प्राइम नंबर, कि मान लीजिए P को एक प्राइम नंबर है, इफ P डिवाइड A स्क्वायर, अगर P जो है किसी A स्क्वायर को डिवाइड कर रहा है, देन P जो है वो A को भी डिवाइड करेगा, और इसमें जो A है वो एक क्या है, पॉजिटिव इंटीजर. ओके, नेक्स्ट इज let the prime factorization of A be as follow. So here take an example of positive integer, then if we factorize that A, so their factors will be like this. So the prime factorization of A is P1, P2, so on and Pn, where P1, P2 and Pn, these are the primes, means these are the prime numbers only, and it is not necessary that they will distinct, means it could be same, so there is no conditions for this to be distinct. All right, therefore A square equals to P1 P2 dash Pn into p1 p2 dash. So after multiplying these, we will get this, that is p1 square comma p2 square and so on pn square. So after multiplying the factor of prime factor of these a into a, that is a into a, it will come p1 and this one.
I hope till here you have understood this.
Okay, next, given p divides a square. So here we have already given that p divide a square. Therefore, from the fundamental theorem of arithmetic, so this theorem we have already discussed in the previous videos. You can check out from there. So therefore, from the fundamental theorem of arithmetic, p is one of the prime factors of a square. So p is any number, means any prime number that is the factor of a square. I'm again repeating, a is something that is positive integer. So the prime factor of a or a square is p, is one of the prime factors of a square. So after that, here we will use uniqueness part of the fundamental theorem. This one is also discussed in the previous one. You can check out from there. So let's go to the next slide. All right, so let's continue this. So next is we realize that only prime factors of a square are p1 comma p2 and so on and pn. So p is one of the prime factors of p1 p2 and pn. It means that from the previous, when we realize that only prime factors, means prime factor of a square are these. For example, any prime number, just imagine any prime number that is a square. So the prime factor of a square are these, p1 and something. So this p is one of the prime factor of these, p1 p2 and so on. Means this is one of the member of these factors. Now since a equals to, means the factor of a are this, so it means that p will divide a. P divides a. So after all of this, we are now ready to give a proof that these root 3, root 3, root 2, root 3, root 5 are irrational numbers. So this was the theorem which will going to definitely help us to prove that these numbers are irrational numbers. So now to prove irrational numbers, we are going to use a method that is, I hope now this one will be visible to you. We will going to use proof by contradiction. All right, so let's go to the next slide to understand the concept of irrational numbers by proofing method by contradiction. Let's go. All right, so let's begin with this, that root 2 is a irrational number. So this is a statement, we need to prove this. So to prove this, we have to assume to the contrary that root 2 is a rational. So it means to prove root 2 is an irrational number, first of all, we have to assume that in contrary way that root 2 is a rational number. And we all know the condition or definition of a rational number, that these are those numbers which can be written in the form of p upon q, and q cannot be equals to 0. So let's start. So first of all, let us assume to the contrary that root 2 is a rational number. Okay. Now next is, let's take some integers like r and s. Here same condition of the rational number. Here we have assumed r and s are the integers, where the condition for the s in the denominator part, that s cannot be equals to 0, such that root 2 equals to r upon s. So that we have assumed that root 2 equals to r upon s, means we assume root 2 is a rational number. Okay. Now suppose R and S have common factor other than 1. Okay. All right. So here we have assumed suppose R and S have common factor other than 1 means कि R and S के कॉमन फैक्टर होंगे 1 के अलावा भी, ये हमने सपोज करना है या फिर कर लिया. ओके, देन वी डिवाइड बाय द कॉमन फैक्टर टू गेट दिस, दैट इज √2 इक्वल्स टू a अपॉन b. हमने क्या किया, इसके बाद हमने डिवाइड किया इसके साथ कॉमन फैक्टर के साथ, ताकि हमें √2 का क्या मिल सके, इक्वल टू क्या मिले, a अपॉन b, इसकी जगह ये मिल सके. अब ये जो a अपॉन b है ये क्या है, वेयर a एंड b आर को प्राइम. नाउ what are co-prime? So co-prime are those number which have no other factor than 1. It means they have only a pair of numbers, a pair of natural numbers, they have only common factor that is 1. Like this is the example 2, 3, 3, 4. Now 2 and 3 and 3 and 4, these are the co-prime pair. They have common factor, that is they share common factor that is 1. 3 and 4 have common factor that is 1. So these are the co-prime. In the same way here √2 equals to a upon b, where a and b are co-prime. I hope till here you have understood. Sorry. Then from here after cross multiply it will become b √2 equals to a, and after this equation squaring both sides we will get this, that is b √2 square equals to a square. So after solving this one, we will get this b into b, that is 2 square, and √2 equals to 2, and this side a square. So from here, therefore 2 divides a square. These 2 divide a square. जब हम इसको इस तरफ लेके जाएंगे तो ये इस तरीके से आ सकता है, means therefore 2 divides a square. I hope आपको यहाँ तक समझ आया होगा. Now why the theorem? अब यहाँ पे बात कर रहे हैं उस थ्योरम की जो हमने अभी इसको करने से पहले समझी थी. अब उस थ्योरम को अप्लाई नहीं करना है, मतलब उसको लिखना नहीं है, जैसे वो हमने पीछे पूरा स्टेटमेंट की तरह समझा था और लिख के देखा था. यहाँ पे अपने वो सब थ्योरम जो है मेंशन करनी है. तो यहाँ पे जस्ट मैंने वो बाय द थ्योरम लिखा है. अब इससे आपने समझ आना है कि हम द प्रीवियस विच वी हैव डन उसकी हम बात कर रहे हैं. सो बाय दैट थ्योरम 2 डिवाइड्स a, 2 डिवाइड यहाँ पे therefore 2 divide a square, it means 2 divide a also. Okay, so here from here we can write a equals to 2c. Now this c is some integer, means some other integer, that is c. You can take an example of c. So after, now here we will use this value a equals to 2c in here in this equation. So after putting the value of a equals to 2c, now this equation will going to be like this, 2b square equals to 2c ka square. It means in place of a square we will put 2c whole square. So 2b square equals to 2 2s are 4, c into c square, 2 divide 4 square 4, it will come 2c square. So after solving this equation it will become b square equals to 2c square. I hope till here you have understood this. Now next let's go for the next slide. All right, so this is the next slide of this topic. So this was the last equation of the, this is the equation of the last slide, that is b square equals to 2c square. From this next one is the, it means that 2 divides b square. So if 2 divides b square, so 2 divides b also. So this concept is used from the previous theorem that we have discussed. So 2 divides b. Therefore a and b have, from all these explanation we get a and b have at least 2 as a common factor. But by this contradicts that we have assumed the fact that a and b in the original have no common factor other than 1. मतलब ये जो a और b के 1 के अलावा कोई और फैक्टर नहीं होना चाहिए था, बट जो हमने assumption क्रिएट करी थी जो भी कि √2 जो है वो एक रैशनल है, उसकी वजह से लास्ट में हमें a और b का 2 जो है एटलीस्ट 2 जो है कॉमन फैक्टर बन गया. बट इसके हिसाब से हमारे पास 1 के अलावा कोई भी कॉमन फैक्टर नहीं होना चाहिए था. सो दिस कॉन्ट्राडिक्शन हैज अराइजन because of our incorrect assumption that the √2 is a rational number. So by this wrong assumption, therefore we have proved that √2 is a irrational number. So this is all about this explanation concept. I hope you have understood all this. So in this same manner we will use the same statement for the other questions of like root 3, root 5 and so on. I know this is the most boring part of this chapter, but we need to understand that these questions are very important in the examination point of view. So I hope आपको ये पूरा चैप्टर जो है, जो चैप्टर का नाम था रियल नंबर्स यानी कि वास्तविक संख्याएं, उसके जितने भी पार्ट्स हैं आपको समझ आए होंगे अच्छे से. अगर अभी तक आपने वो पार्ट्स नहीं देखे हैं तो आप मेरे चैनल पे जा सकते हैं, और ये जो अभी आप वीडियो देख रहे हैं इसके जो डिस्क्रिप्शन में मैंने बाकी के 2 पार्ट्स के जो लिंक जो है वो मेंशन कर दिए हैं, तो वहां से आप जाकर इसके बाकी के जो पिछले पार्ट्स हैं उसको आप देख सकते हैं, ताकि आपको पता लग सके कि पीछे हमने क्या क्या किया था. और अगर आपको ये जो चीज़ें थोड़ी विजिबल नहीं है तो उसको आप जूम करके देख सकते हैं, तो ताकि ये थोड़ा सा आपको विजिबल हो सके, क्योंकि अब बोर्ड पे लिखना है तो स्टेटमेंट काफ़ी लंबी थी, तो उसके लिए हमें थोड़ा सा बार बार लिखना इरेज करना पड़ रहा है, तो छोटा लिख रहे हैं ताकि ज़्यादा जो चीज़ें वो इसमें आ सके. सो दिस इज ऑल अबाउट दिस वीडियो एंड सेशन. Thanks for watching. See you in the next video. Thank you.